First of all, thank you for joining this session. So this session is a KubeEdge deep dive. I'm not. Let me. Yes. So this session is a KubeEdge deep dive. So I'll be starting off with an introduction to what edge computing is. Then we'll move on to the what KubeEdge is, how KubeEdge is used to extend these Kubernetes and other CNCF like cloud native projects to the edge. And then we'll talk about the use cases. I'll also discuss a few case studies here, and then we'll talk about the project graduation updates. So this session was actually going to be given by two of the CNCF KubeEdge maintainers, Fisher Shu and Hongbing, but unfortunately they couldn't come, so now I will be delivering this session. So here's a little bit about myself. My name is Shubham. I am not like an experienced engineer like most of the speakers here, but I have been contributing to KubeEdge and other CNCF projects since last 1.5 years. Other than that, I have also been a Linux Foundation mentorship mentee under CNCF KubeEdge, and I'm also an organization member at KubeEdge. And this will be my first time speaking at KubeCon and Cloud Native Con. So starting off with some good news, KubeEdge has been graduated from CNCF. This happened on October 2024, 2 months ago, and this is all because of the maintainers, the TSC committee, and of course CNCF and the contributors. So a huge thanks to everybody who has been involved in this project. So talking about the project journey, so KubeEdge was started as an open source project in 2018, and then it was donated to CNCF. So it became the first cloud native edge project under CNCF. So I'll highlight a few key milestones in the journey. So this was in 2020 January when KubeEdge saw a large-scale adoption in the China's highway ETC, electronic toll collection. Basically, a KubeEdge-based system was created for collecting toll. So this was like scaled to 100,000 nodes across multiple provinces in China. Back then, we were using multiple clusters for this, but later you will see that the KubeEdge has also added support for 100,000 edge nodes within a single cluster. Then you will see that in 2020 September, KubeEdge became a CNCF incubated project. And on its way, we have also introduced sub-projects like in 2021, we had Sedna and EdgeMesh. So Sedna basically is a tool for improving or enhancing these AI workloads by enabling the collaboration between the edge and the cloud. So the idea is that we would have a lightweight model at the edge, and then there will be a model at the cloud. Then there is EdgeMesh. So EdgeMesh is a networking tool for communication between these edge nodes. And then in 2021 September, we had the first cloud native vehicle that was based on KubeEdge. So KubeEdge here was being used for over-the-air upgrades at the software level. Then we had this first cloud native satellite. So this was in 2021 December, and this is where this cloud and edge integrated solution was tested in space. So basically what happens with these satellites are different than normal edge devices because firstly they would move very fast, then they have a very limited connectivity to the ground station. So basically if a satellite, like in a day, satellite would have 8 to 10 times connection with the ground station, and these sessions would be like for 6 minutes to 10 minutes. So this is very limited connectivity. And you would have heard about this, that in recent years, we have seen the data generation volume has been much more than the data transmission volume. So where KubeEdge was being used here is that KubeEdge and Sedna was reconstructed to create this software which would help push a lightweight model to the satellite so that it can perform real-time filtering of these images or of the data, because in some cases, 80 to 90% of data captured by the satellite would be of no use because it would be like covered with clouds or it would not be useful. So only the data and the images useful will be transmitted back to the ground station. And then in 2022, we introduced support for 100,000 edge nodes in one cluster. Then in 2023, CNCF KubeEdge became first CNCF project to achieve the level 3 SLSA certification. I'll talk about this, and I'll also talk about the satellite part after a few slides. Then in 2024 October, which is 2 months ago, CNCF became KubeEdge became a CNCF graduated project. So a small background about what edge computing is. So basically, edge computing is bringing the workloads as close to the user or as close to the edge as possible, where the data is being generated or where the action is being taken. So if you look at this diagram, you'll see that we have this axis, which is closest to the user, and it has the minimum latency. And then there is aggregation, which would like collect the collect the traffic from multiple accesses. And then there is metro, which has the maximum latency, which is like the connection between the regional edge and the cloud. So based upon these latencies, we have these use cases like for access, we have near side edge and city edge or far edge. These two are have use cases like V2X, like AR, VR, AI, etc. So V2X is like vehicle to everything. It's a technology for vehicles to interact with its environment so that they can perform things like autonomous driving or road safety, etc. And a lightweight model can perform AI inference at this near side edge or city edge. Then for regional edge, typical use cases would be CDNs and AR, VR, or compute heavy tasks like rendering, video transcoding, etc. And then for cloud, we have use cases like big data and AI training, AI inference, etc. So where KubeEdge comes into play is KubeEdge basically provides a consistent experience of these applications and resources, data, services between the edge and the cloud. And the aim with KubeEdge is to bring these cloud native technologies to the edge, is to enable edge computing. So if we look at the data centers or if we look at the cloud, the services are very mature, the infrastructure is very mature, but at the edge, things are still developing. And that's why KubeEdge was created, and that's why KubeEdge was made open source and donated to CNCF, so that we could bring in this community-driven development and this open source development to the project. And we have had great response from the community. At GitHub, we have more than 7,000 stars and more than 2,000 folks. And then we have like more than 1,500 contributors from different organizations and a few student contributors also, like me. Talking about the architecture. So if you look at this, there is cloud side, edge, and the devices. So at the cloud, you'll see Cloud Core, which is basically used to manage these cloud nodes and these edge nodes. This is like for Kubernetes, this is like the control plane, similar to that of Kubernetes. Then the cloud core would communicate with this edge core with a duplex communication channel. This could be with a WebSocket, which is by default. But if you have a low latency environment and if you have if you have to make the communication a lot more quicker, then you can use Quick for this as well. Another important thing I would want to talk about KubeEdge is why not use Kubernetes for the edge. So basically, a simple cluster, a basic cluster with Kubernetes would still require like 1 gigabytes of storage. But so with KubeEdge, what we decided to do was we could have this kubelet, and we could have we made lightweight optimizations on this kubelet so that the resource usage of this kubelet could be reduced to like 70 to 80 megabytes. so which makes it usable for the edge basically. And if we look at the edge part, we have this edge core, which would basically use these container runtimes like Docker and Containerd to manage these pods. And these pods are where the edge applications would be running. And there is edge mesh, which is used for communication between multiple edge nodes or these applications at the edge. Then if you look at the devices part, we have these different protocols. So with mappers, our idea was to decouple the application development with this managing of these protocols. So we have this mapper which would work with these protocols, and then it would send, it would fetch, like if a application is requesting for data, then mapper would fetch that data for that application. Talking about what's new in our latest release. So version 1.19 was released on October, and we have some updates, like we have support for edge node report events. So this is basically, we can report events, like the cloud can ensure that all these pods and nodes are running securely, and it can monitor those by these events, by these edge events. So these edge events would basically reflect the status of edge nodes or of these pods. So this can be used by kubectl get events or kubectl describe. Another thing, these things are not by these are not by default. So you'll have to implement this. You have to basically change settings for this. Then there is support for over-the-air upgrades for the edge nodes. So this improves the reliability, because with over-the-air updates, we can keep our applications more current. And then there is support for mapper for device data writing. And we have added OpenTelemetry to the mapper framework as well. And then there is the new release for the KubeEdge dashboard, which basically now is using Next.js. And you can see the screenshot there for the dashboard. So it's using Next.js and Material UI. So this is device management interface by SIG Device IoT. So with device management interface, our aim was to decouple the part of, like I talked about this, decouple the part of communication with the edge devices with the application development. So the idea basically here is device as a service, so that the applications can interact with these applications can interact with these devices like they interact with these Kubernetes services. So it provides a more flexible and unified way to manage all these IoT devices. If you look at the diagram, you'll see this mapper, which is basically doing all this heavy lifting of working with these different protocols like Modbus, Bluetooth, etc. And this would provide the data to the application at the edge. So some features about DMI are, firstly, we have these lifecycle actions like creating a device, updating, deleting, etc. We can also perform health checks. And then there is updating device twin or reporting the device events. So this is useful for monitoring from the central cloud. And then there are updates like OTA management, and there are also some advanced features like device virtualization, etc. Then the recent updates in this DMI have been, we have added a new device API, and now Mapper also supports data coming as a video streaming form. And then we have also upgraded the support for, we have also added support for upgrading the Mapper. Talking about the edge architecture. So in the recent updates, we have had this support for pre-pulling this image on the edge. So this basically reduces the container startup time, because images can be pulled at the in advance. And then there is support for auto rescaling these edge modules. So this is good for reliability, because anytime we can choose to automatically restart these edge components. And then there is there is support for more device overrides. Basically, this is for improving the flexibility so that these deployments can be specific to the edge environment. If you look at the edge mesh, this is a tool by KubeEdge for communication between various edge nodes. So in earlier versions with edge mesh, we used to have a centralized server which would perform all these communication, through which these communication would be passed on. But now we have come up with this serverless design. So whenever there is communication between two edge nodes, then we have these edge mesh agents on each of these edge nodes. So whenever there is communication, then these edge nodes or these edge mesh agents will step in and perform the responsibility of a server, basically. Then another thing I wanted to talk about was this node level data persistence. Actually, I should have talked about this with KubeEdge. So we also allow for node level data persistence so that even if the edge node would go offline, or even if it is not connected to the control plane, then also it can work and it can recover even if it's offline. Then there is support for layer 4 and layer 7 traffic management. So layer 4 is basically for basic data like TCP and UDP, and then layer 7 is for application level data like HTTP, HTTPS, etc. Then another work in progress is to enable Istio for self-governance. Talking about the SIG security, so KubeEdge has had its third-party security audit by Adalogics. This was in 2022, and KubeEdge became one of the first CNCF projects to reach the level 3 SLSA certification. And then for source, build, and common areas, we have level 4 certification. If you want to read more about these audit reports, you can scan these QR codes. Also, we were one of the first projects to integrate with fuzzing, so this enables KubeEdge to be much less vulnerable, and we can find out these potential security loopholes through fuzzing. Talking about the AI part, so for this we have Sedna. So Sedna basically is a tool for improving or for enhancing these AI workloads by enabling a collaboration between the edge part and the cloud part. So how this basically works is we would have a lightweight model at the edge which would perform this inference, and then we would also have a model at the cloud. So if you look at this diagram, where we have this global manager, which would perform task management and coordination, so that from the central level, from the cloud level, we can execute all these AI workloads. And then it also performs model and dataset management. So this is so that the cloud, or we can have centralized control over the AI model and over the data. And this cloud node will be talking to this edge node through this bridge of local controller. And if you look at both these nodes, you'll see worker. These worker performs the inference. So all this inference and training is performed by the worker. And so because of this edge and cloud collaboration, we have the following training and inference frameworks. So we have joint inference, we have incremental learning, federated learning, and lifelong learning. I'll talk about these individually. But the idea is with joint inference, we want to have, basically for joint inference, we will have a lightweight or a shallow model at the edge, and we will have another model, deep model at the cloud. And if there is a request, and it can be processed locally, it can be processed by inferring the data locally, then it would be done for reducing the latency, and if not, then it will go to the cloud. Then there is incremental learning, which basically is that the model keeps on learning with new data being fed, and then these being accumulated over the cloud. And there is federated learning for data privacy and for security reasons. And then there is lifelong learning, where we basically manage a knowledge library. Talking about the open ecosystem, so we are compatible with most of these popular AR frameworks like popular AI frameworks like TensorFlow, PyTorch, Paddle, etc. So this is the Sedna lifelong learning service. If you look at the diagram, you'll see there is a knowledge library. So this is basically persistently storing all the data that is coming from this edge, and this edge will be performing these tasks, like unseen tasks will be processed at the edge, and all the data will be going to the and persistently be storing at the knowledge library. This is so that we can avoid the problem of catastrophic forgetting. And then basically this knowledge library would perform all the inference here. Then there is a Sedna federated learning service. So idea basically here is that the isolated data at the edge should not leave the edge. This is mostly for security reasons or for compliance reasons. So what happens is, at the edge, we have a local training algorithm which would perform the training at the edge, and the raw data will not be sent at the cloud. Only the model parameters will be updated at the cloud, and cloud will be running this aggregation algorithm. So with this, one more thing I would want to talk about is multitask detection. So with federated learning, actually we have these unbalanced sample sets. So for these for cloud, we have large data set for cloud models, but for edge, for some edge nodes, we may have access to a large data set, and for some edge, we may not have that. So for this, we have multitask detection. Basically, what this does is it divides these non-IID sample sets. So IID is basically non-independent and identically distributed sample sets. So all these tasks that are similar will be grouped together and will be executed together firstly for better accuracy, and then for accuracy. And this is also important because it will help in reducing the resource usage. Talking about the joint inference. So with joint inference, we have a shallow model running at the edge, and we have a deep model that is running in the cloud. So what happens here is that if a request is sent by the user, then and the confidence level is met by inference at the edge, so the response will be returned, or the action will be taken at the edge itself. It will not be connected to cloud. So this way we can have lesser latency, we can reduce the latency, and if the confidence level is not met, it would be inferred in the cloud. So this is how we can find a fine balance between the latency and accuracy or precision. So basically, the AI developers would provide data to train these models at the edge and the cloud, and then business developers would deploy them to the edge. Talking about a few case studies. I have very less time left, so I'll have to be quicker. These case studies, so KubeEdge is being used across industries, from traditional industries like intelligent transportation, like I mentioned, the China's highway ETC system, to these cloud-native industries, like it was used for smart CDN, for cloud-native vehicle, for low Earth orbit satellites, for power industry, and a lot of, you can have a look at this. So let's talk about this low Earth orbit satellite and this case study. So basically, the challenge with satellites are, like, firstly, I mentioned the challenge of it being very fast and having a very limited connectivity. Then there is another challenge of the object recognition precision. So this object recognition precision is also needed to be improved. And then another thing is that with unlike the other edge devices which can be manually upgraded, we cannot do the same with satellites. So with this can only be the longevity of a satellite, and the functionality of a satellite can only be improved through software. So in this case, what we did was with KubeEdge Sedna, and with KubeEdge Sedna and KubeEdge was reconstructed into this satellite, so that we could firstly perform this we could firstly deploy this AI model to the satellite, and this AI model would perform real-time filtering. And other than that, we had this collaborative inference between a large model at the satellite, lightweight model at the satellite, and a large model at the ground station, which basically improved the object recognition precision by more than 50%. And by performing real-time filtering of data, we could reduce the data transmission volume by more than 90%. Like I said, more than 80 to 90% data is not very useful for the ground station. So this satellite was basically used for flood mitigation and for uh, disaster mitigation. So it was very important to reduce the reduce the time of inference here. Then there is smart offshore oil fields. So with oil fields, we have challenges like security and compliance. So we would not want the data to leave the edge and the data to be exposed to the cloud. Then another important thing is for oil fields, we have a lot of these equipments. So for these, we require sensors and devices, and we need to manage these sensors and devices. So with KubeEdge, basically, or actually, Huawei Cloud provides a commercial solution around KubeEdge. So using that, we could perform this. We could basically reduce the cost, and we could do efficiency improvement. This was basically done by firstly, like for preparation of these sensors and preparation of these equipments. These sensors and these devices would take like 7 days, but now we could control them, and we could deploy applications to these edges through KubeEdge directly. Other than that, we also have the option for offline self-healing. Like I talked about, I mentioned this, that we have node-level data persistence. And then there is this unified operations and maintenance management through a central cloud. And we also talked about the federated learning service. So this was used basically for these offshore oil fields to have the data being processed at the edge, and only the model parameters to go to the cloud, to be exposed to the cloud. I have only 8 minutes left. I'll be quick. So this is the open governance model. Basically, all the achievements KubeEdge has had is because of the open governance, because of the community and this governance model. This is inspired from Kubernetes. We have a TSC committee which would lead the project, and we have these SIGs, like you can see the list of 11 SIGs. So these SIGs work on specific projects or specific areas of development like node or device IoT, networking, scalability, etc. And then there are these working groups which are created whenever there is a specific problem and are dissolved after these problems are solved. We talked about this. We have a very diverse partnership across industry and academic institutes and research institutes. So this is very important for us because whenever thinking or whenever bringing up any solutions, we have to take care of a wide set of audience. And then KubeEdge also participates in these, KubeEdge collaborates with Linux Foundation Mentorship Program. So we have been participating in this program for more than 4 years. We have provided more than 20 projects. And it's a great way for young professionals and for student developers to work under the mentorship of these maintainers. Yes. And then this is for partners and case studies. So we have partners like Huawei Cloud, Dow Cloud, CubeSphere, etc. So these partners are important for us because they provide not only they provide contributions to the project, but they also provide these commercial solutions around KubeEdge. So this is how the open source development and these commercial tools are collaborating with one another. And then there are case studies. I talked about 2 of them. There are many more case studies. You can find them at our website, kubeedge.io/case studies. So I think that's all I had to talk about. So if you want to know more about the project, you can visit our website kubeedge.io. And if you have been using KubeEdge and you have any feedback, you can visit our GitHub and you can file any issue. If you have any questions regarding the future of the project, or if you have any questions you would want to ask the maintainers, then you are welcome to our Slack channel, and maintainers will be more than happy to help you there. Other than that, we can take a few questions from here. And I would like to end this with to join us with making the cloud native ubiquitous. So if there are any questions, I can take in. Yes.
Thank you. So you are a student contributor. You confidently present. Thank you for that.
Thank you. Thank you very much.
It's in fact, the contributors like you make the project successful and healthy and sustainable. So one question is quickly summarized. So from your perspective, right? I know that I'm not talking about industry or anything, but from your perspective, other than the the typical the constraint, I mean the capacity requirement of the KubeEdge deployment, right? That's the main constraint. The capacity constraint is the main constraint in an edge.
Yes.
And KubeEdge is somehow managing that constraint requirement. Other than that constraint adaptability, is there any other adaptability required at the edge deployment, and how that KubeEdge is managing it from your thought, from
Yes.
your perspective?
So
because one is constrained, I agree, but other than anything you want to point it out?
yes, so there are resource constraints. Other than that, constraints are like we would require for these control plane and for the edge nodes, we would require a very low latency network between these. So this was another constraint that we had with deploying applications at the edge using Kubernetes. So how this worked was with KubeEdge, what we could do is it is not necessary for the control plane to have a very strong connection with the edge nodes. Basically, this was done by having these edge nodes having local data persistence. So now whenever if edge node is failing or if edge node is offline, then it has local data persistence, so it can it will not forget all the actions it has done before, because it does not require it to be connected to the control plane. So this is another constraint. I think there will be more. So I think maintainers will be able to guide for this more, and I welcome you to join our Slack. Maintainers will be happy to help you with this and to talk you about this. Yes. Mike, please.
Okay, so for a beginner, if one wants to get started with KubeEdge, right, do we need special devices to work with it so that we are able to experiment in the similar constraints for which it is developed for? Is there any requirement for certain specific devices, or we can work with just our laptop?
Actually, you can work with your laptop. So using KubeEdge, you can have the cloud core and the edge core both at the same machine. But for more use cases and for deep diving, you'll have to have different, like an edge and a cloud. But otherwise, you can work on this, and you can work on a single machine, and you can visit kubeedge.io. We have a detailed tutorial for this there.
Okay. One more question I have. Let's say, so I was working on a recent study on a solar power plant, right? So if I have to collect data from there, and rather than just sensing data from there and computing it at my local center, instead of that, if I use KubeEdge, will it help me to expand my, let's say, area of surveillance and collect more data and then compute it then and there at those clusters, and then only use what is meaningful to me onto my central location? Can KubeEdge help me into monitoring solar power plants? Do you think it will be a good idea?
So yes, the application for KubeEdge is basically these. Most of the companies, like KubeEdge has had most of these commercial partners from China, and there are a lot of companies which are using this for like on-device processing and processing near the edge. So it is possible, and I think you can talk to our maintainers. They'll be able to help you how this can be formulated.
Thank you.
Thank you very much.
Any other question?
Yeah, my question is that for the edge core, what kind of OS do you need, and what would be the CPU and memory footprint edge core itself will take? Because anyway, at the edge, the compute requirements, the device is very slim.
So actually, as far as I know, it is built upon Linux, but I'm not very sure about this. So I think maintainers will be able to guide you better about this. So you can please join our Slack, and I can actually talk to you about this outside the room, and we can connect with this.
Okay, sure. And what would be the protocol connectivity over internet between the edge core and the cloud core?
So basically, edge core and cloud core.
Yeah, how would the edge device, is it the HTTPS protocol or is it some other protocol?
So the communication between these happens through WebSockets, and you have another option of Quick as well.
Okay.
So thank you very much for attending.